Hey everybody, good evening. We're at session 9, which means that we are officially in the second half of the course. This is exciting for a couple of reasons. It means that we're halfway done. And it also means that we're going to be turning our attention to some of the more advanced concepts in the course. And that starts tonight. So tonight, we're going to introduce the REST API project, client server. And there's a lot here with this project. So what I'm going to do tonight is I'm going to walk through, I'm going to show you how to create the project, and then we're going to walk through it in quite a bit of detail. We're going to look at the code, and the way we're going to explore the code is by using the Java debugger. And so then, the intent here is that we're able to understand all the moving parts, because this is a distributed program now. We've got a client talking to a server. It's an order of magnitude more complex, and maybe more complex than a lot of the other programs that you've worked with in your time in college. So want to make sure that we can have a good discussion about it, dedicate ample time to it. So tonight we're just going to be looking at the code. We're not going to be modifying it. We're just going to be reading through it to get all the pieces parts. And then on Wednesday, we are going to start refactoring it. So this is going to be sort of an encore to the refactoring that we did last week. But instead, we're going to be refactoring the sample code to turn it into something that looks a little bit more like your project. And so it's a way to sort of explore modifying the code. So this week is going to be all about Project 4. And then I wanted to also skim ahead to the rest of the course. The remainder of the course will be divided between two topics: Android development and mob programming. So next Monday we are going to we're going to do two things next Monday. We're going to I'm going to walk you through how to set up your development environment for building an Android application. So even though I'm not going to assign the project quite yet, I don't do that for another week, I want to make sure that everybody has the ability to run Android Studio, which is the IDE for developing Android, get all the tools working on their development machines. I want to do this with enough time so that if anybody's if Android doesn't work in anybody's environment, that we can find out early and then make other accommodations. It's been a while since there's somebody who's had a laptop configuration that doesn't work for Android, but it's been known to happen. So I want to smoke any problems out nice and early. But then we're going to do mob programming. So I guess another heads up next Monday. We're going to be doing an operating theater exercise, like the way we introduced pair programming. So up here in the front of the room, we'll have a bunch of people mobbing together. I got to admit, it's kind of hard to understand the experience if you're remote. We don't have great cameras trained on everybody. So I do encourage you to attend in person next Monday, even though it's not required. But next Wednesday on the 30th, that your participation is required. We'll be doing our first mob programming activity all in person. So anyway, and then we'll finish out the course, doing more mob programming, learning more about Android, and then that'll be it. So time-wise, we're halfway through the course, but I do acknowledge that sort of project work-wise, we are still very much in the middle of things. So over early this morning, I sent out the graded Project 1 submissions. Project 2 is due on Wednesday, and we assigned Project 3 last week. And then tonight we'll start learning about Project 4. So lots of stuff all happening at the same time. I understand there's a lot going on, but it's all part of what's the meta lesson of the course, which is how to manage a bunch of things. So with that preamble, I wanted to open things up for Prime Minister's questions. What can I tell you about what's happening in the course? I want to hear about your experiences with Project 2. There's been some great questions I have answered on the Slack channel. I encourage you all to check them out because they're very relevant to your projects. But what else would you like to know? Are there questions you'd like to ask, feedback, or observations that you'd like to share? Oh, a question that came in on chat. It may seem early, but what should we expect for the final exam? I'll talk about it more in detail as we get closer to the final exam. Let's see here. Some highlights include, it's worth 12% of your grade. which is not insignificant, but it's not like your entire grade is determined by that. So as a matter of fact, if you go and when we learn about the Android project is worth more than your final exam. So balance your time accordingly. The final exam comes in two parts. There is an individual part and a group part. The group part is not coding. It's working together to solve a problem with critical thinking via critical thinking. You've done, but between your pairing and your mobbing, you've done plenty of coding with others in the class. And then the individual part is essentially two quizzes put together. It's 6 short answer questions, but it's on any topic that's covered in the course. So basically anything that's linked to here on the home page, all of that is in scope of is the final exam. Oh, good question. The final exam is a group part in person. The answer is yes. So yes, please plan to be in class on Wednesday, August 13th. Right, there are 3 times that you are required to be in class. The first pairing activity, the first mobbing activity, and the final exam. We're all going to end the term together and there will not be a remote option. Unless you have like a DRC exemption, or if there's really something that you're anyway. If it's really a problem for you, especially if you know this far in advance, we can work something out. But the expectation is that that final exam takes place. Yes. Yeah. No separate license for Android Studio or for Android development tools. No, it's more a matter of making sure like your machine has the right specs. It's pretty resource intensive, and if anybody is running like a wacky version of Linux or something like that, it may or may not work. But here again, I think experience has shown that it works for pretty much everybody these days. Yeah, they've come a long way. When I first started using it, there were some kind of hokey things you had to do, especially on a Mac, but now it's all working out. Yeah, Denny's still on Windows 98. It will not work. You might want to downgrade to Windows 95 and give it a try. Dude, I hope he wasn't serious. That's all right. How are people feeling about Project 2? Curious about how it works compared to Project 1. Okay, you got a thumbs up, so hopefully it's a relatively straightforward next step. Anything confusing, or anybody scratching their head about anything they'd like to explore? Yeah, file reader and file writer. Yes, and I'm glad that you asked about that, because, yeah, one of the the things that is consistently confusing to people is that wasn't his resource API and the other file IO APIs that we learned about. I think you hit it on the head, right? So for your main program, for the things that the command line program does, yeah, use the file API, the Java IO file API, and the file reader and the file writer, all that kind of stuff. For your unit tests, especially the text parser, yeah, if you want to have like some canned file that it reads, the best way to do that is via a resource. Oh, and you can do that too, right? If yeah, for the certainly the text dumper, you can use the file API directory. File API directly, and then you can use things like the @tempter annotation for your JUnit test if you want. There were some examples of that out of the box, but yeah, I mean, ultimately, if you've got something that works, use that. Nice. Yeah. No, that is good. That gives you some experience with APIs. Yes. Let's see here. Oh yeah, good question. Let's see here. For some tests that failed in the grading of Project 1, should we fix them? Are the same or similar tests going to be used at Project 2? The answer is yes to both. So because Project 2 builds on all the functionality of Project 1, you can expect that some of the test cases from Project 1 will be used again in Project 2. So what I encourage you to do is the following. Regardless of whether or not you got the test case wrong in, or not getting the test case wrong, if you had points deducted for the test case in project one, implement them as an integration test, right? Take the command line that was there in the output that you received from the grader, implement it as an integration test, make assertions about what is written to standard output or standard error, and make sure they pass, make sure they're green. Presumably, if you lost some points, especially a lot of points, it might have meant that your error message was insufficient or something like that. Again, implement them as integration tests and drive them to green, because not only are you going to see them again for project 2, but they'll be someone in project 3 also. And so then you'll just have better code coverage. You'll have a more robust validation if you implement those as integration tests. Yep. Good deal. Anything else for primary answers questions before we dive into project? Oops, that's not tonight. Project 4. Okay. Silence has gotten awkward. Okay. So in the first half of the course, our projects were all about just working on the command line, right? And this is probably the same kind of projects that you've been writing since your very first CS course. It's like the same kind of code that people wrote back in the 70s. Okay, there's a command line, environment, a terminal of some sort, and you are interacting with a program. You're interacting with a single program by invoking it. It takes input from the command line. It does something with that input and generates some output. Whether it's a file is written to disk or there's some text that's printed out to standard output, that's what it does. That's a fine kind of program. Still lots of programs like that in use. But it presupposes that everything runs on the same machine, right? And everything is just all there together. Well, in the second half of the course, we're going to be working with more complex software. And what we're going to see first is a client-server program here in Project 4. So Project 4 continues to evolve your appointment book application by creating a web service that a command line client can interact with. And so then this is where you can apply what you learned about REST and about how to develop, REST, what HTTP is all about, and how to develop web applications in Java. So what I'm going to do now is talk about the assignment and show you the code and get sort of oriented with it. Feel free to follow along at home. But hey, if things go too fast, or there's something that I can do quickly that it takes a longer time in your environment, then feel free to view the recording and come back to it later. So, actually, before I really dive into the details, I want to talk about the architecture. I think for me, this is where I like to start. I'm going to make this as big as I can, because I think this is a fundamental difference between Project 4 and the previous projects. I was going to say Project 5. I apologize. When I teach the 11-week version of the course, it's Project 4. Sorry, it's Project 5, the 11-week version of the course. So, in all your other projects, you've had one program, right? You launch your executable jar. It takes the input, does its thing, does the output, and then it terminates. It's done. In Project 4, there are two programs. Over on the right, we have the web server, something called the JD Web Container. We'll talk more about that later. And that program starts, and it keeps running. That basically runs for a long time, while multiple instances of the client come and go. So there's one command line program for running the server, and another command line program for running the client. And these two programs communicate with each other using a RESTful API implemented over HTTP. Now, I go into lots of detail about HTTP in the web applications lecture, the foundations of the web, which is really must reading must-do reading for this in order to understand just the context of what all is going on. But the whole idea here is that the clients can come and go, and there can be multiple kinds of clients, as we'll see. But the web server remains running. And what's in your web server is a bunch of application logic that maintains your appointment books. Actually, in Project 4, you're going to be maintaining multiple appointment books inside the one web application. You won't be writing them to disk like you do in Project 3. But you will be just holding them there in memory, and that's okay as long as the web server is running. Those appointment books will be available to the clients. And so there's a protocol between the client and the server that is provided by this RESTful API. And as you'll learn about in the lecture, if you haven't watched it already, is that basically what a RESTful API is a convention that's implemented on top of the HTTP protocol that leverages the various HTTP verbs like get, and post, and delete to implement a behavior when accessing what are called resources, basically the URLs that you hit. So when the HTTP client makes a request for a get of a URL like /appointment-book appointments !owner equals Dave, the logic implemented inside your web application will take this request and fulfill it. So in this case, it is going to return all of the appointments in the appointment book. And this is all implemented in something called a servlet. A servlet is a standard Java API for responding to HTTP requests. And so what you'll do is very shortly we'll create the project. And by the way, this is a new Maven project for Project 4. And we'll take a look at all. And out of the box, there's a working application that implements a simple dictionary, key value pairs, both words and definitions. And that gives you the framework for the appointment book application. And what your job is to take that out-of-the-box dictionary application and morph it into your appointment book application, leveraging the code that you've written for previous projects for the appointment book, your text dumper, and your pretty printer. And along the way, you'll be using a lot of APIs for implementing the servlet and for invoking the REST API. And so I think before I really dive into the details of the project, and of course you can read it here in the PDF, let's play with the code. Let's take a look at what we're doing and how to use it. So the first thing that we're going to do is we're going to I'm going to log into the PSU machine, and I am going to create a new project for the REST API. So I'm going to go to my code checkout, which is in Git. It's my repository, and so this will be JavaCoding Coding Summer 2025. I'm going to make sure I've got the right, run my sh key here. So I've typed my passphrase once. Now I'm going to pull down the latest changes. I don't know if there's anything to pull down or not. Nice. Oh, I'm on the GitHub Pages branch. Branch am I on? No, I'm on main. Okay, good. Okay. It looks like it, okay, I had some changes. Oh yeah, I probably made those changes last week when we talked about the website. Okay, so now, and this is detailed in here someplace. Sorry, I'm kind of skipping all over the place, but. There's a script called create, where to go? Yep, create REST project. And so then this is what we, create REST project. Is it indeed bigger? Make it bigger, I see it's squinting. Sure, okay. So let's go off and create a new Maven project. This is just like what you did when you created your project 1 and when you created your koans project. Okay. And it creates a new directory called appointment book -web. And so I'm going to add that and the modified pom.xml to Git, and I'm going to commit it. Added REST API project. Great, and I'm going to push it. Oops. Now, the as we'll see here, the appointment book project is just another Maven project, and you can use the same commands that you did for your other one. So I'm going to run Maven w clean verify. And I just want to make sure that all the code builds before I start modifying it or messing with it. And this will do for this web project exactly what it does for your other command line projects, the projects 1, 2, and 3. Right? Again, clean will like blow away any generated artifacts, all those live in the target directory. It'll then build a project. It'll compile the source code, it'll compile the unit test, run the unit test, compile the integration test, run the integration test, and make sure that everything passes. And it does. That's good. That gives me confidence I'm working with a solid foundation. So I did this on the PSU machines just to make sure that it works on the PSU machines. Now I'm going to go back to my local laptop by logging out over here. And now I'm going to go over to, so I have my local checkout here. I'm going to go over to IntelliJ, and I'm going to pull down the, going to update the project, which will fetch all the branches, and it will get all the latest changes for main that I just added for the REST project. Oops, it does something. I don't know. It's something about my display is messed up. Okay. Now I should see, yep, I have a new project here because I synchronized with Maven automatically. Now I have an appointment book web project. So this is cool. And if we look, it's got stuff that should seem familiar to you, like main directory, test directory, the integration test, all that good stuff. And if I look at the main though, it's got some Java code in it, and it's got this web app directory. Now we don't actually. Well, we might change the index.html eventually. But for tonight, I'm just going to say that this is all stuff that's required for your web application. There isn't anything that you're going to need to change in it, that you're required to change in it. Instead, we're just going to look at all this Java code that's here. So there are some things that might look familiar to you, like a text dumper and a text parser, also a pretty printer. But then there's some things that are new to you, like the appointment book servlet and the appointment book REST client. Before we look at the code, I want to show you what this code does. So I am going to, so for me, the picture that I have in my head, the picture that I recommend that you have in your head throughout all of this, is this one right here, where we talk, this is the architecture of the application. Over here on the right, we have the web container. This is the long-running process that handles all of the requests that come from various clients, HTTP clients, such as the command line. I'm going to run these programs now, and I'm going to do that from two separate shells because I've got, I'm going to try to make them the same size font so we can see it easily. I'm going to have them both in the same directory. Because what we're doing here is we're running two programs at the same time, right? Oops. We're running, over here on the right, we're running the web container, and over here on the left, we'll be running the command line program. So the way you run the web container is that you use Maven, and you run a, so the web container is an open source piece of software called Jetty. There is, and you'll learn about this in the lecture, there is a standard API called the Servlet API that provides, again, handles HTTP requests. And the Jetty web container, well, implements that API as a web server, right? It's the thing that runs, and there's a port on which it listens for requests, and it handles the request, and ultimately uses the Jetty API to redirect a request, or really route a request, to a piece of Java code that handles that request, right? This is how you respond to the asynchronous HTTP requests that come into your web application. So the way you run that is you say Maven Jetty, oh wait, I'm not on the right directory. I need to be in the web directory. And then you say Maven Jetty :run. There we go. And oops, what this will do is it'll build the project, and then it will run Jetty. This is one of the nice things about Maven. right? So Maven, because it's, we talked about this last week, because it's standard, it's easy for the people that provide the Jetty web container to write a Maven plugin that allows you to do Maven stuff. Okay, great. So it looks like it's running. Everything's okay. There's a lot of output here. Probably the interesting thing is the following. It says that it's hosting it's hosting content, or will respond to running on localhost port 8080. Are you all familiar with the concept of what a port is in software computing? I hope, right? It's like a conceptual hole in the back of your computer where stuff comes in, right? Okay, and there's a number associated with it. And so, actually, I think the first thing I want to show you is not so much the command line, but I want to open it up in a web browser because we're probably all familiar with how to work with stuff in the browser. So here, I open my web browser, and I want to say I want to go to HTTP. Oops, not S. HTTP ://localhost:8080. And so what this is doing is it's saying, hey, listen, make an HTTP request, a GET request of this URL, which is which basically is running on port 8080 of my local machine. And when it does this, what actually happens is it hits this Jetty server running over here on the right, and it says, hey, listen, I don't know how to respond to this one, but I can tell you that there's something called appointment book. Well, that's good, we want that. So we're going to click on that to go there. And this returns a canned HTML, not canned, an HTML file, HTML content that is served up by my application, our application. And actually, you can find the source for this in the index.html, it's a little bit bigger, file here in the source code. So we can modify this, hey, I can just say, I can just sort of say here, I can say, hello, everyone. Oh, what did the AI want to say? No, there it is. Anyway, so I'm going to say hello, everyone there. I modified the source code here. And so what I need to do is I need to restart my Jetty. So I'll Control-C it and run it again. Yeah, there are some you can configure Jetty to load it automatically. It doesn't really help us that much in this case, and sometimes it gets it wrong. So it's easier for me just to stop and restart it. And now when I go and I reload the page, now it says hello everyone. So just to demonstrate to you, it's like, hey, listen, we are serving up something from our application. So as I said in the over here, you've got this web container that's running, and it knows how to respond to HTTP requests. Now, for the project, those HTTP requests are going to come from, well, actually, those HTTP requests can come from any source. And for the project, you're going to implement a Java client that sends the HTTP request. But for the purposes of demonstration, I found that it's easier to start with using a web browser, right? Which is the way you're used to interacting with a website or interacting with programs that support HTTP. And out of the box, as I was saying, this application implements a simple dictionary where you can define words, a word with a definition, and then you can see all the words in the dictionary. So here I'm going to create a new one, and it has the same things from last year. I'm going to say, hey, the definition of doe is a deer, a female deer. Right? Everybody loves the sound. Okay, I'll submit that. And submitting it made a request back to the server, and you can see that it was a post request. And the application will log the fact that it received a post request that mapped the word doe to a deer, a female deer. Now I can go back in the browser and back here on on this page, and now I can get the definition of the word doe, and this will I'll click submit here, and you'll notice up here in the URL bar, it's now loading. It's doing an HTTP GET of the URL localhost:8080/appointment book/appointments ? Word = doe. And so this is a form of REST API. It also looks just like you would any application that any web application. But the whole idea is that we are fetching a resource, in this case appointment book/appointments, with the parameters word = doe. And when you ask for this, it returns doe colon a deer, a female deer. And just like before, I'm gonna minimize this so we can see things left to right. I'm going, and again, it prints out the output get doe when I make that request. Don't need this much screen real estate, so I want to see things happen in real time. So let's do another example here. Now I'm going to use this other form here, and when I click submit to list all word definition pairs, it goes to the following URL. It goes to appointment book/appointments, no parameters. And over here on the right, it prints get all dictionary entries. So what I hope you take away from this demonstration is that when I do stuff over here on the left with the browser, stuff happens over here on the right. You've got two programs talking with each other. You've got the web browser program and the servlet, or the Jetty web container, communicating with each other over HTTP. And because they're using HTTP, it provides this interface, this protocol, in HTTP, that the two programs can use to talk to each other. And because they because HTTP is standard, different kinds of clients can implement, can talk with the server. So I'm going to do one more thing. I'm going to add another. Let's see, I'm going to add another word in the dictionary. Ray, a drop of golden sun. I need to make that field longer. I'm going to click submit. Now we have another, another dictionary entry there. So the index.html is included in the project for demonstration purposes. It's actually some code that's contributed by a student. They wrote all the HTML forms, and it's actually, I think it's a good way to get started with it so you can see what it's doing. But how the vast majority, I don't want Chrome, I want this. The vast majority of things, let's see here, I probably want one of these. No, I don't want that one, I want the other one. Oh, no, this is an old one, actually, I think you can get rid of it. Good. Well, how I really want to interact with the program is through the command line tool. Okay. So the command line tool is built, it actually is built just like your command line tools from the first couple of projects. It's an executable jar file. I'm going to run that with just Maven package. So that will build the jar file. I don't think we've used Maven package here before, but if you go and watch the Maven lecture, Maven package builds the artifact for the project. In this case, it'll be the client jar. Great. And so now when we say Java -jar target appointment book -client.jar. So the name of the jar is a little different from the one from your other projects. It says, okay, good. This is the main method. Here it says missing command line arguments and tells you what it is, what arguments it takes. So it takes a host and a port and an optional word and an optional definition. So if I run this with the host and port, so the local host is the host and 8080 is the port. As I hope you saw, it makes a call to the server to get all the dictionary entries and it prints them out. Doe, deer, female deer, ray, a drop of golden sun. I can use this to create a new entry in the dictionary. Say me, a name I call myself, and it prints out, hey, you defined me as a name I call myself, and over here it received a post which maps the word me to the definition a name I call myself. And if I go back over here and I list all the words and definitions that are in the dictionary, now you see that you've got 3 of them. You've got me, Doe, and Ray. Notice they're not stored in order, but it doesn't matter. Yeah, question. Good question. What do you think will happen if you stop the server? If I were to stop the server? Exactly. So, and that's a very good point. So, if you didn't hear, you speculated that, hey, probably if I stop the server, then I'll lose all my data because everything's stored in memory. And that is correct. We're not writing to disk in this, and that's fine for this. Of course, if you were working in the real world, you would have the data persisted because, I mean, gosh, you're maintaining your dictionary, right? You get kicked out of Oxford, or whatever. Um, yeah, so let's just see it in action. So if I Control C my Jetty to stop it, and then now if I try to reload this, it'll get a site can't be reached. And if I try to use the command line to print everything, it gets connection refused. Okay, good, because the server's down. So now let's run the server again. Start it back up again. Okay, it's running, and now I'm going to run it again, and it says 0 words in the dictionary because everything's been gone. Yep. And for project 4, this is perfectly fine behavior. In projects 2 and 3, you demonstrated that you can write to a file. It's not super important to do it again. You'll actually do it again in the Android application, but yeah, I know you can do that. So I don't ask you to do that. Oh, it looks like the get was called twice because this page refreshed out from underneath me, and it made a get call to the server. That's cool. So this is what ultimately you'll need to do in Project 4. Instead of having this dictionary application, you're going to be having your appointment book application. You're going to be able to perform many of the same, it's big again because we're going to talk about Project 4, many of the same operations with this client-server application that you did in your previous projects. So the command line is going to look a little different for project 4. Actually, the arguments are going to be the same, right? You're going to have the owner, the description, the begin time, and the end time. And notice the begin and the end are the format that's used in project 3, so the 12-hour format, the 24-hour format that's from projects 1 and 2. And then you're going to have some different options. So remember, this is for the command line program. So you're going to have host and port, dash host and dash port. There's a dash search, which I'll explain in a little bit. You also have dash print. So because every time you run the program, well, not every time, but when you run the program with all 4 arguments, then you're creating a new appointment book. A new appointment, and you'll print the new appointment there. And of course, there's the dash read. So here are several functions that are performed by the client. Here's an example of adding an appointment to the server. So you'll run the main method here with the client jar. You'll provide dash host and dash port, and then the 4 arguments spread across whatever that is, 6, 8 command line arguments, or command line program arguments. So you'll have your owner, Dave, and a description is teaching class, and it goes from this date and this time to that date and that time. So that's kind of fundamental capabilities that you've had since Project 1. In Project 4, the command line will also be able to search between appointments that begin at 2 different times. So here, what it should do is it should pretty print, so using your pretty printer, all the appointments that begin in the month of November, because it starts on November 1st and ends on November 30th. If there's no appointment between those 2 times, you should get an error message saying so. And so here, we run with dash host, dash port, dash search. The name of the owner of the appointment book is required, and then you don't provide a description. Instead, you just provide a begin time and an end time. It's not the begin and end time of an appointment. It's the begin and end time of the search range. And finally, if you just provide dash search with an owner, then it'll print all of the appointments it'll pretty print all of the appointments in an appointment book. The idea here is that for Project 4, you're able to reuse a lot of code, including your appointment and your appointment book, and your and your pretty printer. And also, as we'll see, your text dumper and your text parser. And I'll scroll back up above and get into some of those details here. But I do want to call out a couple more things about the command line program. As always, you should exit the program should exit gracefully under all reasonable error conditions, like hey, something wrong with your command line. For instance, the date and time is formatted. Also, hey, if you can't establish connection to a server, don't just issue don't just have it throw an exception. Catch that thing and print out a nice message. Or if the data that's passed to the REST URL is not correctly formatted, right? We want to, and actually this is an important point. You want to validate the data that comes in at the server side. And in addition to the client on the command line, you want to make sure that you want the server to be protected against malformed data. And actually, this is a really important thing to do because, well, this is how so many web services get hacked. Is that they don't do maybe they do validation like on the client side in the user interface, but they also need to do fairly robust data validation on the server side to make sure that bad or malicious data doesn't get into the system. Yeah.
I have a question about the option like with and all.
Yes.
Here you specify the owner name.
Yes.
Would we have multiple performance books in the server?
Yes. Yeah. You picked up on an important aspect of the assignment. The server maintains multiple appointment books, right, for multiple owners. So whereas in projects 2 and 3, you had the text file that only contains the appointments for a single owner, now you have an application that supports multiple appointment books for multiple owners. Yep, great question. If there's anything in the chat, is there not?
So is the expectation that the host and port options are required? If they're not there, should our program just get back what it did?
That's a good question. You know what? Ask that question again in chat so we can look at the test cases. So the question was, hey, do we need to degenerate down to like project 1 functionality if we have the 4 arguments and dash print or something like that?
Yeah.
I don't think so. I think other than the dash readme option, I think I always provide host and port because, I mean, you've already demonstrated that you know how to do that in project 1 and 2. So I don't think that's terribly interesting at this point. But if you post on in the class channel, I'll go back and look at the test cases just to make sure that yes, for all intents and purposes, dash host and dash port are required. Or I'll say they will always be present in when I test. Okay. So I'm going to talk about the requirements of the servlet, but then we're going to look at the servlet code, and I think things will make much more sense to you. So the servlet is the object that responds to the HTTP requests. We'll look at the API here very shortly, but the whole idea is that you provide methods that say, okay, when I get an HTTP GET request, here's what I do. And when I get an HTTP POST request, here's what I do. And the here's what I do depends on a couple of things. It depends on 2 things primarily. One is the HTTP verb that's used, like a GET or a POST. And then also, the URL or the resource that is, that is specified in the HTTP request. So ultimately, what your appointment book servlet object needs to do is the following. When it receives a request for a URL like /appointment book /appointments !owner equals name, if it receives so this URL, when it receives a GET request, will return all the appointments in the appointment book owned by that owner using your text dumper. So here's something interesting. The wire format of the data that's passed back and forth is your text format, which I guess makes sense. Now, of course, in the real world, some people say, "Oh, I should use JSON or I should use XML." Yeah, fine. You're gonna have to write enough code for this anyway. Here, we'll just use the text dumper to return data back to the client. But it does reinforce that in a REST API, you need to be deliberate about what data format you use to shuttle the data between the server and the client. Now, if the servlet receives a post to this URL, that's a cue to create a new appointment from the parameters owner and description, begin and end. So basically what the command line program will do is that if it detects that you are looking to add a new appointment, then it'll craft an HTTP request that uses post and then provides those parameters, the values of the parameters that are passed in on the command line before it's validated. In the case that an appointment book doesn't exist, please just create a new one. Right, there isn't a separate command to create an appointment book or a separate REST API, a separate HTTP method to create an appointment book. Instead, it always supports adding an appointment. So that's one piece of functionality that the appointment book servlet needs to implement. And then there is basically the API, the REST API that searches for appointments. So if you have a URL that's again your appointment book / appointments, and you specify the owner, the begin and the end, the begin date time and the end date time, then what this will do is it will return all of the appointments to the client, formatted again using the text dumper, that begin between the begin and end time, that basically occur between the begin and end times. That was just like the example that we talked about below. Note that the format of the date and time is the same as the command line, including spaces. So you gotta make sure that you properly encode, or that you need to make sure that spaces are properly encoded. You should get that for free, but we'll see that in a little bit. And oh yes, by the way, the web application supports multiple appointment books because you can have different owner names. So it's not an error to specify an owner name that's different from another one that was already provided to you. So that, in a nutshell, is the requirements of the application. As you can see, there's a goodly amount of stuff here, and very shortly we'll start looking at the code. Before we do that, I did want to pause for anything that you'd like to discuss in terms of observations, anything that might be a little confusing or unclear here at the get-go. Okay. I want to explore the code, and I'll do the following. I'm going to start by walking through. Let's take a look at the servlet. Okay. So I'm going to quick sort of peruse the code, and then we'll go back and use the debugger to look at it in detail. So we have a couple of constants here. These are the parameters that are supported in the URL. These are the things that occur after the question mark, right? And so then when we look at, oops, sorry, I want to go back to Chrome. We go back to the application, and we go and we define a word, and then I'm going to ask the definition of array. I hit submit. Note that the URL is appointment book / appointments word equals array. So this word is the parameter that's passed in, and the value of that parameter is array. So here in we have two parameters that the application supports, word and definition. For that get query, we use word, but when we post, when we create a new pairing, we provide both the word and the definition parameters. Actually, before we even talk about the constants, I should probably talk about the class itself. So this appointment book servlet extends something called HTTP servlet. Now, HTTP servlet is a standard class that's part of the servlet API. This is basically it basically says this is an object that knows how to respond to HTTP requests. And the whole idea is that the servlet API provides the glue, the interface between the web container, so the Jetty web container, and then your application. That's why I depicted the web container application as I did. So when you run Jetty, Jetty itself starts up. And what Jetty knows how to do is support Java web applications. As you learn in the lecture, Java web applications are bundled together in something called a WAR file, a web archive. And inside that web archive is all the code that you as the developer provide for that web application. And for this, relatively simple a web application that we're developing, the most important thing in there is the appointment book servlet. And so this source code for the servlet gets compiled into a class file, it's bundled into a WAR file, and deployed to the Jetty web container. And what Jetty does is when it receives, so Jetty has all of the mechanism for opening up the port on HTTPS port, and for implementing the HTTP protocol. And so then it listens on that port, and when it receives a message, it makes sure that's a valid HTTP request, that all the right stuff is in there according to the protocol. And then what it attempts to do is route that request off to your servlet. And the appointment book web application, when it registers itself with Jetty, says, oh yeah, I know how to respond to URL requests made to the /appointment book. Sorry, that was loud. Made to the /appointment book URL. So that /appointment book here, when Jetty sees that, it's like, oh, that goes to the appointment book application. And then inside the appointment book application, it knows to route /appointments, so /appointment book /appointments, off to your appointment book servlet. All this configuration is taken care of for you. I don't need you to be dealing with that kind of stuff. I want to be focusing on the code. So all that stuff comes built for you as part of the application. And so what you as a developer need to do is implement the appointment book servlet to do something interesting, to then respond to the GET request or the POST request that is ultimately made by the client. And the way the servlet API works is as follows. The servlet API, the superclass, provides methods like doGet and doPost, which specify what happens when this servlet receives a GET request. The signature of this method is provided two arguments. The first is an object that represents the request. So this is an object that is actually passed in from the container. So it's the container that creates this object and passes it to the doGet method. So you don't create this object. You instead, you being the servlet instead receives this from Jetty. So it sends you a request, and it gives you a object that represents the response. And the job of this doGet method is to perform the logic of the program based on, well, the inputs from the request and the output, and send the outputs to the response. So basically, what this does, I want to dive into the debugger first. So that's what doGet does ultimately. It'll implement the GET capabilities, and we'll see what that does in a minute. Similarly for doPost. So it goes and it interrogates the request object to find out, hey, what parameters were I sent, and then it will, based on that, it'll say, great, I want to send this particular output back to the user, and it'll do that via the response. And so it's actually kind of cool the way this works, right? It's a really great abstraction. So Jetty does a lot of the heavy lifting. And basically what its responsibility is like, hey, listen, I see this request, I know where to send it to, but ultimately it bottoms out in code that you write to provide the logic of your application. Now, this code is complex, really, but I do want to explore. I do want to explore it in real time under the debugger. Now let's see here. Who here has used a debugger before? Everybody, I hope, good. Like GDB or something like command line or whatever. Ever used a debugger in like an IDE or a UI or anything like that? Okay, good. So hopefully these concepts are familiar to you, even though you probably haven't done, or you may or may not have done Java debugging. So in order to debug a program in Java, you need to configure the VM to allow a debugger to attach to it. Right, just sort of like, you don't want, as a matter of fact, it's very rare that you actually want a Java program, especially something running in production, to have a debugger attached to it. So you have to explicitly configure the VM to allow a debugger to attach to it. So so IntelliJ actually makes it really easy to configure all of this stuff. And so you do it as follows. We're going to go up to our Run Configurations menu, and we're going to say Edit Configurations. And we're going to create a new run configuration. Now, actually, as you'll see, the ones that are already here, this is all like running of tests, of integration tests, right? It's an invocation of a Java program. But here I want a special invocation of a Java program, which is I basically want to take my IntelliJ and attach it to my Tomcat, or sorry, not to my Tomcat, to my Jetty, which is running in a different VM, right? It's running over here on the command line. It'll be running over here on the right, and I want to connect to it with the IntelliJ debugger. So what I do is I create a new configuration, and it'll be the remote JVM debug. Yep. And I want to give it some information. I want to say the following. I want to say Jetty on port 5005, and this will be running on localhost on port 5005. A very important distinction. The port for debugging is different from the port for serving HTTP. In this case, we are going to have the Tomcat VM. I'll have open up multiple ports. One port will be the port that it serves HTTP content on and is connected to by HTTP clients like the web browser or the command line tool. And the other one will be the port that is used for debugging. And it'll sit there and wait for a Java debugger to attach to it. And then once it does, then we'll see that we're able to pause code execution and walk through the code as executed. So you configure your remote configuration with a port and a host. There are other options here, but what you get here is this -agent lib stuff right here. And this is actually an option to the JVM itself that you can put on the JVM's command line that will run the JVM in a mode that it can be in debuggable mode, so that a debugger can attach to it. I'm going to click here to copy this, copy it to the clipboard, and I'm going to do the following. Now I need to stop my Jetty because I need to run it differently. What I'm going to do is I'm going to enable debugging, actually to set an extra JVM parameter for the Maven VM, for the VM that runs Maven. I'm going to set an environment variable. I'm going to call it Maven Ops. Well, it is called Maven Ops. And the value is a thing that I added to the clipboard from IntelliJ. It's the -agent, all this kind of stuff. I'm going to set that environment variable. And now when I run my Jetty, I think we'll see this as listening for transport on 5005. So this is saying, it's kind of a cryptic message, but what it's saying is like, listen, I'm waiting for a debugger to attach to me on port 5005. And it's doing that. So I'm going to create this configuration and say Jetty on 5005. I'm going to click the debug icon. And what that will do is that it'll launch the debugger in IntelliJ, and it will, that's good to know. And it's saying, hey, I connected the debugger, connected to the target VM on port 5005. Cool. And now what I can do is I can set breakpoints in the code that will that the debugger will then stop at, and so I can step through the execution. The way I do that is I click in the margin next to a line of code, an executable line of code, and see the line number is now replaced with a red dot to indicate that this is a breakpoint. Also, the line is highlighted in red to say this is a breakpoint in the debugger. And now, when we, so I'll set one here in my get method and in my post method. These are the two most interesting methods in the class. These are the ones that respond to the servlet invocations or HTTP requests. And now I'm going to go back to my browser. I'm going to make my browser narrow again. Maybe no, I probably don't have to. And now I'm going to go back to the HTML page here. And now I'm going to make a get call. I'm going to do the following. I'm going to say, hey, list the definition for the word ray. Actually, I'm going to turn off the debugger. I'm going to detach the debugger momentarily just so we can see what this does. When I list the definition for the word ray, I get a 404 error because ray doesn't exist, right? There's nothing in my dictionary right now. Because I just restarted Jetty, there's no appointments in the dictionary. So when I ask for definition of a word that doesn't exist, it returns a 404, which is a very like HTTP thing to do, right? If you're asked for a resource that doesn't exist, you return error code 404. Now let's walk through that code in the debugger to see how it does this. So I'm going to once again attach my debugger to the JVM. And I'm merely going to reload the page, which will send the GET request to the servlet again. I hit reload, and then IntelliJ pops up because it just detected that a breakpoint was, the debugger breakpoint was hit. In this case, it's in the doGet method. So this is not surprising. We sent a GET request with this URL, so appointment book / appointments _ word equals Ray. That went to Jetty, right? That went to Jetty here, and it ended up routing the request to my appointment book / appointments all the way to my GET method because, well, it was invoked with GET. Now here I am in my code. And so I'm going to use the debug lines like step over and step into and step out of to see what this code does. Now the first thing that this code does is it interacts with the response object, with the HTTP servlet response saying, hey, the type of data that I'm going to return is plain text. This is almost always the first thing that you want to do in a response is to figure out, to say, hey, here is the content type that'll help with encoding and things like that. So for this code, we always just deal with plain text. So now I'm going to go to the next line after we do that. Now, the next thing we do is we want to find out, because what we're doing here is we are, we're printing the definition of a word, or we're returning, rather, the definition of a word. So we want to find out what word is being requested. In this case, it's going to be Ray. The way we find this out is we ask the request, hey, what is the value of the word parameter? And so I have this method getParameter that does exactly that. It interrogates the request object and asks, hey, what is the value of the word parameter, in which case is just the string word. So let's see what that method does. So I can use the debugger to step into the getParameter method. GetParameter is still in the appointment book servlet class. It's a little bit later down. It's on line 157. What this code does is it asks the request object that was sent in from the servlet, hey, what is the value of the parameter with the name of word? So I call this parameter name, but whatever. Now, I want to highlight a couple of things about the IntelliJ debugger. Down here, it is, now that I'm in a method, it is telling me a couple of things. Over here on the left, it's giving me the call stack, right? Just like with an exception, you have methods calling other methods. And here I can navigate to where I am, the doGet method, by clicking on doGet, and then I can go to where the breakpoint is set by clicking on getParameter. And over here on the right, I can see the values of various variables and parameters and fields in the class. In the object that I'm working with. So I can get information about the instance of servlet right here. That's the this variable here in the method. As we can see, our dictionary has 0 entries in it. It's also got something called config, which is inherited from Jetty. I don't think I need to know that right now. It has you can see the value of the name. Value of the parameter name. You can also command I think if you hover over it, it'll also pop up the value there. It gives you a preview of what it is over there, which is pretty cool. And then you can also interrogate information about your parameters, like request in this case. So this is an object. The request object is something that is an instance of a Jetty object and has all this wacky information, which just looking at it like this isn't terribly interesting. But what you can do is you can use the debugger to evaluate an expression. So you can do it here in down here in the field, but I also like to use right-click and I just like to say evaluate expression. And now you can just sort of type some Java code. I want to say, hey, what is the value of request.get? I don't know, get URL, get request URL. Do request URI as a string. I can click evaluate, and oops, I need to make it bigger. Yeah, because the result is hidden for some reason. It tells me that the request URI is /appointment book /appointments. Well, that's exactly what I passed in there. I wonder what happens if I get the entire URL. How do I get those? How do I get the parameters? Oh, great. There's the whole. Well, there's the whole URL, but it doesn't have the parameters on it. Why doesn't it have parameters? So let's see here. Get. You can see this is like all the methods that you can invoke on this object. This is what you can do in the debugger. Or you can sit there and play with your data and inspect things and perform operations on it to better understand it. Yeah, I mean, I guess I can say something like get query string, and then this will return word equals array, right? So in a URL, everything after to the right of the question mark is called the query string, and it's these key value pairs that are passed in as parameters. So we say great, it's word equals array. Also, I'm just showing you how to use the debugger and to get more information about your Java code. So back to what we're doing here, we're getting the value of a parameter of the given name, and I'm going to step over this call to request.getParameter. I don't want to step into it because let's go into Jetty code. And the value here is Ray. Actually, it even tells you the value here is Ray. But what this code does is make sure that that it doesn't that if you get a null value or get an empty string back, they'll just return null because the parameter wasn't provided, which isn't necessarily a bad thing. But instead, what we're going to do is we're going to because the value is not null or an empty string, it's what is it complaining about here? Just curious. Oh, but it is empty. Yes or no? It's going to just return the value of Ray. And so now when I step over that, it actually pops up the stack because that method returned. And now I'm debugging, well, back kind of where I started, but now when I go to the next one, is now the get parameter method is now returned the word Ray. And so what I'm going to do here is I'm going to say, hey, if the word doesn't equal null, which it does not, I'm going to step over that. It's going to call this log method, which and say just print out the fact that we got a get for word. Actually, I'm just going to step into that. As we'll see, all it does is prints the standard out. So this is your servlet printing the standard out, and when it does this, right, this is what prints get Ray right here. So what you see over here in the terminal is the standard output of your Jetty server, of your servlet actually, which is running inside your Jetty. And so now we're going to go back up. Okay, we just logged that, and now we're going to call write definition. So now this is a method here in the class that writes the definition to the response of whatever word. So we're going to write the definition of Ray. So let's step into this. Okay. The dictionary field in this class, I'm going to navigate to its declaration by doing Command B. This is a string that is the dictionary, right? This has the words and the definitions of the dictionary. And so it's a map of string to strings. Okay, that's cool. And so we're going to call the get method on that dictionary for Ray. Now the definition is null because Ray is not defined. So what are we going to do? We're going to say, listen, we don't know the definition for this. And the way we convey this back to the client is by issuing a 404. And so the way we're going to do that is set the status for this response. So the response is going to say, hey, listen, we're sending it back a 404, SC not found. What does SC stand for? Something code? Servlet code, maybe? 404. And really that's it. We're done after that. So we're going to tell the response, hey, send back the 404. Actually, maybe I should say more strictly, we're going to configure the response to have a status code of 404. I'm going to step over that. And now we're done with this method. So we've handled the request. We've written the definition. And now we're done with our get method. And if I step out of this, step over that, I'm back in like Jetty code someplace. I don't need to debug this anymore. I've done my things. I'm going to click resume program. And now, I guess you really can't tell, but here in my browser, I still get a 404. So as you can see, the page is loaded. It's not loading anymore. And I get a 404. So that's what this code does essentially. right? It gets the HTTP request, and then it performs some logic on it. And the logic isn't terribly complex, right? It just says, hey, is there, is there the parameter that I expect there? Does that word, is that word in the dictionary? If not, in this case it wasn't, it prints out it returns a 404. And that's how you debug. I also wanted to show you what you can do in the debugger in terms of inspecting objects and the running methods as they're executing. Are there any concepts that I covered that you'd like to explore a little bit more? Anything there that was unfamiliar, or are there any questions that you're left with? Yeah. Excellent question. The question was, do I need to modify the index.html? Do I need to submit the index.html? The answer is no. I'm not going to test anything with the index.html. I include it as a nice example here in class. And for anybody, like, I don't know, if you're like an old school HTML programmer and you like think in forms and things like that, great, you can use it, help develop, but it's not part of what's tested for your course. For the project, you do not need to get it working. Great question. Okay, didn't see any questions coming in chat. It's time for a break. Let's take 10. We will return at 7:21 and continue learning about the application through debugging. So in the first half of class, we talked about the REST API project. We created the code, and we talked about the architecture of the project, and keep coming back to this picture of the fact that you've got two programs talking to each other. You've got the Jetty web container, and then some client. In this case, it's command line client. But we also saw how we can use the web browser to interact with the REST API because it's all HTTP. And so as long as the client speaks HTTP, then it can interact with the server. And then we use the debugger to set a breakpoint in the doGet method and use that to walk through the code. Now, I mean, this is simple enough code that we could probably just like talk to it, but I wanted to show you how you can use the debugger to interact with the code because I think more so than your other projects, this is kind of complex and it's asynchronous. I think fundamentally the complexity comes from the fact that your code isn't in a straight line anymore. It doesn't always begin with the first line of code in your main method and then end with the last line. It's interacting with this long-lived process in the Jetty server whose entry points are like this doGet method or the doPost method. And this is where the client, this is where your code starts executing, not in the main method. Before I dive into more things, is there anything that came up during break that you'd like to talk about? Anything that is on your mind or anything that I can expand upon from the start of class? Yeah. Yeah, the .war file, yeah. Yeah. There's lots more details in the lecture, but the whole idea is, it was the following. Okay. So in your first couple of projects, you built jar files, Java archives. What Java archives are is like basically a tar file, a zip file. It's a file that contains a bunch of other files. And the files are in a format such that, well, Java programs know what to do with it. And so then in projects 1, 2, and 3, we created these executable jar files where you can run, actually we created one in project 4 also, right? So if we go and look at the client, when we run the client, we say java-jar, and then we give the name of the jar file, and that sort of is the program. It's the artifact that's created by the project, and it's the thing that you sort of would pass around and share with others. The war file is another archive of files that represents the web application. So it has all the code and all of the resources like the index.html and something called a web.xml that configure the web application. And actually, I guess we can look at it. Although I don't know if it's built. Now that I think about it, do we have a war file? Yeah, appointmentbook.war. So we can use it's also a jar file. So we can say jar.tf for table of contents of the file, target/appointmentbook.war. we look at the output here. Actually, let me show you the jar. I don't think we looked at the jar file first. We haven't looked at the jar file yet. So if we look at the appointment book client .jar, we look at the contents of it here. We'll see it's got a couple of things. It's got something called the manifest, which basically describes the WAR file. And then it's got a directory structure, and then it's got a bunch of class files, right? And so these are all of the files that you need to run the client side of your code. It's got the main class. We haven't talked about these things yet, but project 4, and then it's got the the pretty printer and the text dumper. Actually, it includes the servlet. It doesn't need it, but that's basically everything. Oh, and the appointment book REST client. That's an important thing. So we'll be looking at this stuff shortly. So this is what's there in the jar file. Similarly for the WAR file, we look at the WAR file. It's got a lot of the same stuff. It's got the manifest. It's got a bunch of directories, but it's got things like the index.html. It's got this error page for the errors. It's got it's got all the code that you need. It includes the client-side stuff because I'm just for simplicity, everything's all in one place. It also has a whole bunch of third-party libraries that it needs, and this specifies things like the actually lots of this in there that's just included by default, but like it needs actually none of this stuff is. I don't think we use any of this stuff here. Oh, I guess it uses the examples. No, it would use the project. Where's the project share? Yeah, projects. Right, so this is the code that contains like abstract appointment book and stuff like that. It's all bundled there in the WAR file. And the whole idea is that you give Jetty the WAR files, like go run this application, and it's got all the stuff it needs for the application.
So, like, the server just runs something like the appointment book server?
It does. But so it does, the server runs the appointment book servlet, but it runs it in the context of the WAR file. Because it needs to know things, basically, the WAR file has the configuration to say, hey, here's what happens when you receive, a request for / appointment book. It's like, oh yeah, when it's / appointments, route the request to an appointment book servlet. When it's index.html, display the index.html file. Things like that. So yeah, all that configuration is there in the WAR file, and the WAR file has a standard format. So Jetty, Jetty doesn't know, the open source Jetty people don't know anything about our little appointment book application. But because we create a WAR file, which is a standard format, and because we leverage the standard servlet API, we can all talk to each other. Yay, programming to the interface, right? So, great questions. And again, more information is available in the lecture. Okay, sweet. Now, I want to start talking about the appointment book REST client. But first I want to do the following. I want to walk through some more of the server-side code. I'm gonna instead of using the web form, I'm going to use the client just so that we get a little more used to things. So I am going to run the executable jar again. With that host and that port, and I'm going to define Ray as a drop of golden sun. I'm going to run that, and IntelliJ pops up again because now I've hit another breakpoint. I hit the breakpoint for the do-post method. And let's quickly walk through this, just to get a little more practice here. We're going to step over things. So just like in the do-get, the first thing we're going to do is set the content type. So, hey, I'm sending you plain text back. It's going to, once again, get the word parameter. And here, I'll let you know that the HTTP post request contains a word of Ray and then a definition of a drop of golden sun. So, and actually, we could see this, I guess, if we then interrogated the request. So, yeah, let's do evaluate expression, and we can say request. Actually, we just had it here. Get query string. Oh yeah, there's no query string because it's an HTTP post, right? I can say get parameters, parameter map maybe, because yeah, parameter map. And as we can see, I'm gonna get a little bit bigger. Hope we can see. It's got two, so this is a map of the parameters, and it's got two parameters, definition and word. Definition is drop of golden sun, and word is Ray. So again, this is the data that's passed from the command line through the HTTP request to actually pass from the command line through the HTTP request, as a post in this case, and all the way to the do post method of the appointment book servlet. And we can use the Java debugger to tell us more information about that request. We're going to get the value of the word parameter. That's going to be Ray. If this were missing, then we would throw an error. We wouldn't throw an error. We would return a HTTP error code. I think it's like 401 or something. We have the word. We're going to use the same get parameter method to get the definition. And that's going to be a drop of golden sun. And now we're going to log the fact that we're posting the word and the definition. Shows up here in the standard output. Now we're going to do like the logic of the program. Finally, here again, this is a dirt simple program. What do we do with this information? Well, we put it in the dictionary. Okay, we put it in the dictionary. And now we can inspect our dictionary. We can say the dictionary now has one entry, Ray, a drop of golden sun. And now we're going to, we're going to format a nice little word response, or a nice little, sorry. We're going to do the following. We have posted the word, we have put the word in the dictionary, and now as part of the response, we're going to include a message that says, hey, we defined the word Ray as a drop of golden sun. And it does it with this code. So the response has a get writer method, and this returns a print writer that lets you print content back to the response. I really like this API because the servlet API chose to reuse Java I/O print writer. Right? You learned about this, in the for project 2. You learned about a print writer, and you get to use it. You get to use that same knowledge for the project 4 with the servlet API, because instead of inventing their own way of writing text to the HTTP servlet response, they said, great, we'll just use a print writer. Hey, here's a print writer. So I like this because we know how to use it. So then I'm going to get that print writer. I'm going to print a little message saying, yep, we defined Ray as a golden sun. We're going to flush the contents of a print writer, make sure it all gets written out to whatever memory buffer it's in. And then we're going to say this response was good, right? HTTP okay, 200. Everybody's great. And that's it. That's what we're going to do. And now we're done with this method, and so then we'll just return here. And now, and then we've posted Ray drop of golden sun here, and we've and the program exits. Right? All the program does is it makes HTTP post request and then prints out the result. The result was defined Ray as a drop of golden sun, and it's happy with it. So it's done its job. Now, anyway, that was the post method. The post method is really pretty simple, right? All it does is it extracts the word in the definition, puts it into the map, prints out a little message, and goes on its merry way. Now let's ask for the definition of Ray. This will return us to the doGet method, right? Because when we want the definition of something, we use the get method. And now we're going to say, hey, we are getting the definition of the word Ray. So Ray is not null this time. In our previous example, it was null. So we're going to say, great, we're getting that word. No, sorry. The definition was null before. We're going to dive into write definition now. We're going to look up the word Ray in the dictionary. And this time, the definition is going to be a drop of golden sun. So it's not null. Now we're going to do the following. Now we're going to write, we're going to write the definition back to the HTTP response. And just like your appointment book servlet, we're going to use something called a text dumper to do that. This is an example of how to integrate the text dumper into your doGet method. So we're going to get that print writer again from the servlet. And we're going to, so the text dumper takes a map It takes the dictionary, the map of strings to strings. That's where the domain object here, much like your appointment book. And so I'm going to create a new one just for this one word right here. I'm going to create a text dumper that dumps to that print writer, and then I'm going to call its dump method. Now the intent here is that this silly little text dumper for oh, isn't that interesting? Oh, this is not the right text dumper. Sorry, that is not the right text dumper. We want it gets a little confusing out of the box here because sorry, where's my servlet? Oh, I'm so lost. Oops, yeah, servlet. There's a servlet. Yeah. So the text dumper here is actually we want this text dumper. This text dumper is a simple text dumper that's inspired by the real ones that you write. And actually next on Wednesday we'll refactor all of this to have to be a real text dumper. But what it does is that it's meant to be replaced by your text dumper because ultimately what we'll be dealing with here is not strings in a dictionary. You'll be dealing with appointments and appointment books. But what this text dumper does, actually, so this doesn't find the right code, so it's going to be hard to debug. Yeah, that goes to the wrong place. I apologize. Basically, what it does is you send in a writer, and then you iterate over it, and you just print out, word : definition. That's what it gets out of here. The thing that I want to point out about this text dumper is that it has nothing to do with servlets. As a matter of fact, I think you should be able to use your text dumper. You should have exactly the same code for your Project 4 text dumper that you do as your Project 3 or Project 2, right? As long as you've abstracted everything away, so if you're using a writer and a file writer, you ought to be able to just pass in the print writer from HTTP servlet request to your text dumper and have it do its thing, right? This is why I've been encouraging you to program to the interface. To keep things at a high level, all of a sudden you can reuse the same code in completely different situations. So instead of dumping an appointment book to a file, you can use exactly the same code, and I mean exactly the same code, to dump it to an HTTP request, HTTP response. I think there's a lot of power in that. So anyway, no moral judgment if you have to adjust a couple things to get it to work, but the intent is that you can reuse a class like text dumper in a completely different situation because you're programming to the interface or using abstractions like writer, and you haven't tied yourself to a particular implementation like a file writer. So now let's just go back to here. Let's see here. Can I just want to say step out? Good. This will return us back here. We've dumped the definition to the print writer, and we successfully fulfill this request. So their code will be 200, or the status code will be 200, and we'll go back. I guess this is the end of the write definition method, and here we are at the end of do get. So let's continue on here. And sure enough, the program exits after printing what was returned to it: Ray, a drop of golden sun. So this is more of a debugging of the servlet, right? You're seeing how the command line program makes various HTTP requests. We can do exactly the same thing with the web UI, or sorry, with the HTML forms. If we say, give me the definition of Ray, it'll go off and hit the do get method again, go through exactly the same code. And so I'm just going to continue. I'm going to resume the program here. And it prints back, and it prints out or returns the same content: Ray : a drop of golden sun. So this is the text dumper format there. Yeah.
I have a question. So when the client sends a request, how would it how would it send a request as it did? How would you send that request?
Yep. We're going to look at that next. So yeah, I mean, I think now that we've explored the servlet side of the code, let's explore the client side of the code next. Great question, though. Okay. Now, the client side of the code starts with project 4. Project 4 is where your main method resides. Not surprisingly, let's just walk through some of this code. It parses the command line by iterating over the arguments and picks out the host name, the port, the word, and the definition. If you have experience with command line arguments, it detects all of that. It does a little bit of validation, making sure there's a host and a port. It parses the port, and if the port's messed up, then it'll again have print a usage message and return. I think things are interesting here on line 60. So I'm going to set a debugger point there because I want to start working through this code at line 60. Now, I want to debug this code, and this code is run from the command line. So I want to, as you may recall, over here in Jetty, we set that Maven ops environment variable set to tell Maven to run so that a debugger can attach. Well, I want to do the same thing now for my command line program. So I'm going to go back to IntelliJ, and I'm going to create another configuration for a remote debug VM. Sorry, remote JVM debug. I'm going to add a new configuration. It's going to be remote JVM debug again. I'm going to call it project 4. And I'm going to call it main and I need to choose a different port because 505 is already used for Jetty. Now I'm going to have port 506 here. And when I updated 506 here, notice that it changed the option here. So I'm going to copy this. And now I'm going to go over here, and when I run my Java program, I'm going to add that option to the JVM, so it's got to be before my -jar. It's a JVM argument saying, hey, when you launch this JVM, launch it in a way that it can attach on port 5006. When I run it, it says listening for transport socket on line 5006. So I want to save this over here. And when I do that, IntelliJ is like, oh, I'm calling do get. Okay, that's great. That's great. I don't want this right now. I'm just going to continue on. But when I run it, I don't have a chance to attach the debugger because it already started. So when I debug the command line client, I need to change this value of suspend to Y. What this will do is that as soon as it launches the JVM, it'll sit here and wait for the debugger to attach. And now I can debug. I can run my main on 5006 configuration here, and now it'll attach with a debugger. Yeah, I'll attach with a debugger. And now it hits. I'm here in my project 4, which unfortunately cannot be seen. That's obnoxious. There we go. I'm here in my project 4 class, and it stopped on the line that I set the debug breakpoint on because it already parsed the command line and found the localhost, the port, and the word. And now let's see what this code does. So actually, before I dive into it, let me show the picture here. So project 5, project 4. In this case, the drawing's wrong. Project 4 uses an object called appointment book REST client to interact with the server. If you go and watch the lecture, you'll learn about APIs like the URL API, the Java.net URL, and the URL connection. This is all pretty low-level stuff for making HTTP calls. And I didn't want you to have to write that code from scratch, so I wrote some code for you that makes it easy. And over the years, I've kind of evolved it such that what you end up with is objects on the client side that abstract out all of the REST API, which, when you think about it, is probably what you want. I mean, if you're the main method, do you really want to know that you're dealing with URL connections and things like that? No, you just want to have an object that you deal with that speaks the language of the application, which are going to be appointments and appointment books. Right now, they're strings. And then, so then what the appointment book REST client does is basically provides a bridge between the main method that just deals with things like words and definitions. The REST client then takes the word and definition information and translates it into the low-level URL calls, the HTTP calls. So let's take a look at some of that code now. So the first thing I'm going to do, now that I've parsed my command line and I have my host and port, I'm going to create this object called an appointment book REST client. And the appointment book REST client is the thing that interacts with the servlet ultimately. And so let's see here. Word is not null, so I'm not going to do. I'm not going to be there. So I'm going to start using the command keys because all this clicking is driving me crazy. I'm going to go F8 to step over. Definition is null, so we're going to do the following. We are going to invoke this getDefinition method from our REST client, and getDefinition will go off and call. We'll call the REST API. So I'm going to step into this method, and it's going to ask me which method it wants me to dive into. I'm going to click on getDefinition because that's the method that I want to debug. And now I'm here in my appointment book REST client class. Let's take a quick look at what you've got here. The appointment book REST client has this HTTP helper object. This is a class that I wrote that basically takes care of all of the formatting of the HTTP request and making sure that the low-level URL and URL connection APIs are used correctly. So it abstracts all that out. And so while on the one hand, it's nice for you that you have to worry about all the low-level calls, on the other hand, you still need to understand how to use these higher-level calls, the higher-level API that I've written here in HTTP request helper. And it also knows what web app and servlet that you're using. This is the thing that basically forms the URL. So this keeps all the logic in one place. And this is a design principle for objects or object programming that states that an object or class should do one thing and do it well. Well, the one thing that it does and the one thing it does well is formats the requests and then delegates off to the HTTP request helper to do the heavy lifting. And so the method that I'm in is the getDefinition method. And what it does is, the first thing it does is it goes off and makes the REST call by calling the get method of our HTTP helper. And so what it does, so the get method of HTTP helper, I'm just going to dive into that here. I suppose actually I could do this in the debugger, couldn't I? I'm going to step into this method, into the get method. And what the get method does is it takes the key value list of query parameters, basically the stuff that appears in the URL, like word equals ray in this case. Remember, this is on the client side. So this is code that you don't have to write. This is all there for you. But basically, what it does is it puts together the HTTP query, and if there is something interesting to put, it goes and adds the question mark. And then it uses the lower level URL class, the URL connection to make a GET request. And it returns this object called a response, which then lets you interact with the response returned from the low level HTTP request. Oh, I went next, and IntelliJ then brought me over to the debug session for the server, because now the server-side code is being invoked. So I want to show what happened there. The last, where we left off, and actually you can see here in IntelliJ. IntelliJ has two debugging sessions going on. It has one for the Jetty on 505, and has one for main on 5006. And notice it's interesting. It's saying that no threads are available. That's not exactly what I was expecting. But basically, this thing, this debugging session is now waiting for the HTTP call to return. And so IntelliJ said, well, now we're executing code on the server. This is kind of neat, but not really what I'm interested in. So actually, I'm not going to just end this debugging session because I don't think we're going to need to debug anything on the server side anymore. So I'm just going to stop. I'm going to detach from the Jetty VM. Oh, and it's going to say stop. I don't really want to stop. What I want to do is detach, but I think this will be the right thing. Right? I disconnected there, but my Jetty is still running. That's good. Actually, oh, it's interesting. It said, oh yeah, I'm waiting for someone else to attach. If someone else wants to debug me, I don't right now. And so now I detach from Jetty, and I think that will then bring me back to, yes, that'll now bring me back to the get definition method because get has returned. It returned that response. And so let's step one more. And now I can look at the response object. The response has the HTTP status code, which is 200 because it successfully found the definition of ray. And then the content of the response is the string ray, a drop of golden sun. So this is some of the helper code that I provide you to be able to get the result of that HTTP GET. As soon as it gets the response, it calls this throw exception if not OK HTTP status, which basically, well, it does what it says. It says, hey, listen, if the status code that I got from that response is not OK, then throw an exception. And I have to, this is something that, from a design standpoint, I struggled with because I have this appointment book REST client that does things like go and go fetch me the definition. What is that definition? And so what I really want, I want my get definition method to return a string. But what do I do when something goes wrong? Well, like if I asked for the definition of a word that doesn't exist, it's going to return a 404. I really don't want my main method to be dealing with things like HTTP status code. So instead, I'm going to throw an exception. Sorry, I'm going to go back to this. I'm going to throw what I call a REST exception. And this is something that I wrote. It's part of the HTTP request helper. I'll throw a REST exception if the response that comes back is not a 200. And that way, my main method can catch the REST exception, and it feels more like Java code and not so much like REST API code. Anyway, this is a little design decision that I made. The HTTP request was OK, so there's no exception that's thrown. And then what I'm going to do is I'm going to get the content of the HTTP response, which is the string ray colon a drop of golden sun. And as you may recall, the do get method will print out the definition using the text dumper. And so now on the client side, I'm going to take that text that was written using the text dumper format. I'm going to use the text parser to then parse that to get the, well, when I call parse, it's going to return a map. And so then here, I'm going to step into this. I'm going to step into the, actually, I don't want that. I want to step over that. I want to step into the parse method. Here's my, and once again, it's found the wrong one because I have two classes with the same name. I'm going to, let's go back to my project 1 class, which has fallen off the face of the earth, or project 4 class. And I'm going to go find my text parser. Text parser is just the analog to the text dumper, right? It's the little out of the box one, which you ought to be able to replace with your text dumper. And so it goes through and it parses it, uses a little regular expression to find the key and the value pair. And so it just goes through and looks at each line and does that. Throws a parser exception if something isn't formatted correctly. Oh, and what it does is it creates a map with the word and definition values. Just like yours creates an appointment book and then then populates the appointments inside it. So then ultimately, this goes back to, actually, let me go from my debugging window again. And not in the parse method so much as, let's see here, if I just say step out. Yep. Good, so we parsed that content and it returned a map, and then we called the get method on the map that ultimately will return the definition of ray. That's what we want to do in our get definition method. So when we're done with that, we return back to our main method. And then we call this format dictionary entry, which will basically pretty print that one word and its definition. And that is the message that we ultimately print out to the messages ray, and then with an arrow, because this is the pretty format, a drop of golden sun. And then we print out the message to standard output. Yep, there it is, ray, a drop of golden sun. And now we're at the bottom of our main method, and so we'll just continue on our merry way. And the program exits. So that's what the command line program does. The main method goes through and parses the command line, but then delegates a whole bunch of the work off to the appointment book REST client, so that we have a nice isolated class that does all of the necessary translation required to convert the strings that are passed, the string dictionary information that's passed in from the main method to those REST calls that are then made to the server, and then the appointment book REST client also handles the response from the REST API from the server, and then turns it back into the strings in the dictionary that the main method understands. Next time we're going to refactor all this code to start making it look more like an appointment book application. But I wanted to start here because this is much more simple. Yeah. On the client side, we can if you'd like. I can walk through it right now. Okay, let's do that. Although, anything else before we do that? Any other ideas, thoughts people want to share? Yeah, let's look at the code path for post. So here we want to create a new dictionary entry. So we'll provide both the word and its definition on the command line. The name I call myself. I'm going to run it again with the debugging enabled. And oh, it's waiting for a debugger to attach. So now I'm going to run the main debugging again. Okay, here we are back in the appointment client. And here now we've got both a word and its definition. So let's just step through this. Oops, sorry, it went a little too fast, or there was a delay. So word is not null, definition is not null. So we're going to end up here, which is post the word definition pair. And so what we do is we call the add dictionary entry method here of the client. So let's dive into that. And now what it does is it calls this post to my URL method with a map containing the word parameter followed by the word that's passed in, which is me, and then the definition parameter. So basically the key value pairs, right? The key value pairs for that describe the key value pairs that are the post parameters. We'll say that much. Yep. It is, yes, ultimately, yeah. And let's take a look at that. So, it gives this map, and so let's step into that. Let's step into the post to my URL method, and this provides a map which is word, me, and definition, a name I call myself. So those are the parameters that we end up sending to the HTTP post request. And then we just call HTTP, this is the HTTP helper, and then the post method. So you don't really need to know what the details are here, but let's debug it because I'm sure we're all curious, or some people are curious. And then let's see here. Oh yeah, so we are in. We got to do a bunch of stuff because we're form encoding. And again, this is what this is not the kind of code that I want you to write. I'll write this for you. And so we first have to URL encode the parameters because they're coming in as as form data. So we'll step over that, and like our data, as you can see here, like definition and name I call myself now has these pluses as spaces because that's what URL encoding does. Now we've got the URL encoded string. We will we'll create a new URL object, and here again use these APIs that I learned, I figured out how to use, so you don't have to. So again, we get the we're going to do a post here. And then we get the output stream writer to get the response back from the server. And sorry. what we need to do is we need to, this is the connection. We basically need to write the encoded data as the body of the HTTP request because it's a post. We do that. We go off and we go and make the connection to the server. We call the REST API, and then we have our response object. And then let's just go back up to where we called it. And now we have our response. And our response contains status code 200. And then the content is defined to me as the name I call myself. And as you may recall, that is also that happens on the server side. The server side responds to the post and writes back and populates the dictionary on the server side and puts the message defined, me as a name I call myself, in the HTTP response. Again, we're going to check to see if there's an exception. Or rather, there's a non-200. It is not, so there will not be an exception thrown. And then this returns back. Well, we don't do anything special here. We say, okay, great. We're going to have a little message here that prints that we defined the word, and then that's it. So the bottom line, and I went through this pretty quickly, but the bottom line is that there's a whole bunch of responsibility that's delegated to the HTTP request helper, right? You don't need to do all of that. You can instead use my code, but you kind of need to know what it does. You need to know how it does it. So, I hope you can see how we can then, and we'll dive into this on Wednesday. We'll morph this application from dealing with the strings to dealing with appointments. Okay. Yeah.
We go over the big things and entries part.
Yeah. Okay. Yeah. You picked up on something there. Yeah. Let's go look at the HTTP request helper. Yeah, things get a little confusing, and let's see here. Oh, you said sorry. The dictionary as entries. Like where? I post my URL here. Yeah, this right here. Okay. Yeah, let me run through this again because there is a subtlety here, and I think it's one of the deficiencies of this example because I use maps of strings to strings for two kind of different things. So okay, we'll say for a long way to run. Wait for the debugger. Debugger attaches. Great. We'll go through all this again. We are adding dictionary entry. Okay, and we'll post to my URL. Okay. Yeah, so the dictionary entries here, maybe this isn't the right, that might be a very good variable name. Probably what's a better variable name is URL parameters or maybe URL parameters is a better name, so I should change that. URL parameters, because that's really what that is. Because you've got the URL parameter word and the URL parameter. How about a URL parameter keys and values? Maybe that's a better way to say it. Maybe that's a clear expression of what that is. So yeah, this is not the dictionary itself. This is not the map that's returned by the, well, it's not the map that's returned by, say, get all dictionary entries, right? This is the map of strings that will contain all the dictionary entries. This is a map of string to string, which is passed to the post method of the HTTP helper. Yeah, it gets confusing. It'll be more clear on Wednesday when we have a separate concept for the appointment book from like the HTTP parameters. Yes. Good point. The URL, so yeah, this method right here, the post to my URL, The URL isn't here. The URL is actually inside the HTTP object. So right here in the post, if we look at this, this is the thing that has the URL string in it right here. Yeah. Yep. Yeah. And again, the intent is that you don't really need to like dive into this too deeply, but you're curious, and I think, yeah, you're like, wait, where's the URL come from? Then it's constructed in the HTTP request helper, which actually is initialized here in this constructor. It basically puts together the HTTP from the host name, the port, and then the web app, which is appointment book, and the servlet, which is appointments. Yeah, and then yeah, that's a good point. And then this appointment book REST client is created up here. Yep, with the host name and port. Yeah, so then if we dive into this thing, it sends in the host name and port. It then formats the entire URL with the web app and the servlet, and then this is basically the URL that's used for the HTTP request helper. Yep. The host name is passed into the command line. Right. Yeah. Yep. Yeah. No. Good. Yeah. There's a lot of code here. This is why I didn't want to make you write even more code with having to figure out the URL class and the URL connection class. Good. So those are the pieces. This thing's still running in days. So I'm just going to continue on. And now we're having more stuff in the dictionary. Actually, I can just do this, I suppose. If I run with 0 arguments, or sorry, if I only run with the host and the port, then it will, I should probably walk through this too, just so we understand. So I'll just say rerun this. Now when we have no word, then we print all the dictionary entries. And here we go and we call the get with no query parameters. And so then here the response that comes back is the entire dictionary. It's definition of far and definition of me, and definition of Ray, right? It's like all the dictionaries and stuff, or all the entries. And because it has a colon, this is in the text format. And so then after we make sure that there was no exception that was thrown, then we get the content from the response and send it to the text parser. And so then it parses it and returns, the dictionary, the map of string to string. And then that map is the definitions of the 3 words. Then we use the pretty printer to format it to a string. We dump the dictionary to the pretty printer, and then the message that gets printed out by the main method is the pretty version of the string and of the dictionary. And it's pretty because it has an arrow instead of a colon. And then that's it. And then we're done. We print it out. And we're done with the program. So there, yep, we get all 3 words. That's the pretty format of it. That's essentially what you have to do with your appointment book, where there's a number of steps to go from here to your appointment book. Yeah. Yeah. I mean, so, and let's give it a try. So over here, I'm going to log into. My. Let's see if we can do it. We can use a remote machine here. I don't know if port 8080. I don't know if it's open on these machines or not. So if I go to my source code again, and I run my Maven, so I'm on Rita right now. And you don't need to do this. As a matter of fact, I don't know. This is just a proof of concept. This is not something. I will always run your client and your server on the same machine. Let's just keep it a little simple. So if I run with not localhost 8080, but Rita dot C .cat.pdx.edu. I don't remember what the full name is. Oh, I don't want debugger on anymore. Nope, it says while contacting the server. Okay, probably can't find Rita. So at CS. Is CS or CCS? I don't know. Let's. Okay, so let's see if we can ping. Actually, here I'm just going to host name. There we go. Okay, now we know. CCS PDX.edu port 8080. Well, just thinking about it. Maybe not. Yeah, so port 8080 might not be open. They locked stuff down on those machines a little while ago, which is a good thing. So yeah, it won't work. So yeah, I don't have a good example of talking in between two machines. Although I might, anyway, you might be able to do it between two PSU machines, but don't spend time doing that. Yeah, this isn't going to work. So actually, I don't. I can also try. No, I'm curious. Can I do HTTPS? No, HTTP. I don't know why this would work though. This probably wouldn't work. Yeah, it's just going to time out. So it probably doesn't accept the connection, or if it does, it just sort of hangs there, which is fine. We really don't want those machines to have ports that are open. Totally cool. Anyway, but yeah, so what you would do is if you did have something, yeah, or, you know, if you're hosting it in AWS or Google Cloud Platform or whatever, you just provide that. Sweet. So that's the pieces parts of this program. And so you've got two processes that talk to each other. You can debug them independently. There's, you know, it's kind of this onion design on both sides, where you've got, you know, classes that, you know, obviously use other objects and your servlet and all kind of stuff like that. Yeah, so that's your code. I had one more topic that I want to cover briefly. We're just going to touch on it, but before I move on, though, is there anything else that I can tell you? Yeah. Yep. Yeah, good point. Yeah, so then, so for yeah, that's a good question for Wednesday's class. So yeah, I'm going to be making a bunch of changes in my repository, and so either you can go through and you know, yeah, watch the video. Probably not. You probably don't want to follow along with me because it'll be pretty fast, and probably not going to go with me. You can go back and apply the same changes, or you can just go to my repository and like copy stuff in. You know, that's fine too. So yeah. Now, one thing, and I think the pacing was a little off. One thing I didn't get to really talk about in a meaningful, I haven't talked about yet, I'll just cover it, is testing these projects. Actually, this is going to be really important for next time, so I'm going to like try to figure out how to, I think I'll spend the beginning of class on Wednesday introducing how to test these projects. So you can have unit tests for, well, rather, Project 4 has unit tests. And so things like the text dumper. Here's a simple little test that makes sure the text dumper and text parser, you know, work. And here is a unit test for oh, that's probably not a good example. Well, anyway, we can also have unit tests for the appointment book and appointment book servlet test. But here's the thing, looking at your servlet, you want to be able to test your do-get method. Well, your do-get method is required to take like this servlet request object and the servlet response object. And if you want to write a unit test for this method, if you want to call this method, you got to provide it with those methods. So you got to provide it with those objects. You got to create your own. And the way you do this is that the way that you do this is by using a library called Mockito, which allows you to create what are called mock objects. And this is some real magic. And so we'll go into it at the beginning of class on Wednesday. But basically what it allows you to do is to call your method like doGet, and the request that you send in is this pretend instance of HTTP servlet request. HTTP servlet request is an interface. And there's this library called Mockito that allows you to say things like, just give me an object that represents that interface, or that implements that interface. Same thing with a response, just give me an object. And then what you can do is you can use these APIs like the when from Mockito to basically like program this mock object to behave the way that you want. So listen, hey, when getWriter from the response is returned, and recall the getWriter is the print writer that, that contains the content that is ultimately delivered back to the client from the HTTP response. When the code under test calls getWriter, then return this print writer that I've mocked out right here. Because I don't need real objects in this case. I want to use all these mock objects. What we'll see on Wednesday is that you can program, I use the word program, you can basically specify the behavior of these mock objects in such a way that you can test your servlet. You can test your servlet using a plain old unit test. So you don't need to be running Jetty. You don't need to create a whole bunch of serverless stuff around it. You can basically, give it you can give it the objects that you would get inside Jetty, but you don't have to actually be running inside Jetty. And this is actually a super powerful thing, and allows you to write fast-running unit tests for code that is normally run inside a much slower running web container. And so we'll dive into things like the when and the verify next time. Although I really encourage you to watch the testing with mock objects screencast before Wednesday to give you some better context. So in Project 4, there are unit tests for your servlet, and we'll be taking a test-driven approach to refactoring on Wednesday. And so we will be walking through what these tests do. And so there are unit tests that use mock objects for your appointment book your appointment book servlet and the appointment book REST client. So this is kind of an interesting one where you can actually mock out the behavior of the HTTP request helper to make sure the REST client interacts with the helper in the way that you expect. So basically, when you say something like, "Hey, give me give me all the dictionaries." Give me all the dictionary entries from the client. Well, we've basically programmed the HTTP request helper for the client to say, hey, whenever I receive an empty map, which is what is passed to it in the get all dictionaries entry, then just return, yep, my sample dictionary, my test dictionary here as text, which is this is basically mocking out the behavior of the server side of the HTTP get, the do get method. And again, what this allows you to do is unit test your code using true unit tests, and so it's nice and fast. The other thing that we're going to see on Wednesday is the integration tests. Now, in projects 1, 2, and 3, the integration tests ran your main method, right? That's what it does. And we said those tests are a little different because your main method interacts with standard output and standard error, and so we needed the invoke main test case framework to capture what's written to standard output and standard error. In Project 4, our integration tests are different. They're more advanced than that. The integration tests execute against a running Jetty server. So when you run your integration tests, it actually interacts with Jetty. So let's see here. I'm going to go back to my machine. I'm going to run Jetty again. I'm going to start it up. And now I'm going to run my Project 4 integration test. Actually, that's a bad example. I'm going to run my appointment book REST client integration test. And here, I'm actually making, from this integration test, I'm making REST calls to the server. So here, there's nothing output. But now when I run my integration tests, they all pass, and look, there was all this stuff that was outputted because those tests interacted with it. And so this is more of a true integration test, right? Where you are testing the client-side code against an actual running server. And I'm going to quit out of Jetty here in the command line because when I then run, I'll do it over in this terminal, when I run maven w clean verify, recall that when you run maven verify, it runs all of your integration tests. Well, this Maven project is configured to launch Jetty with the WAR file, with the web application, kind of all in line here before it runs the unit test. So this is another great example of the stuff you can do with Maven, right? It will start Jetty for you, it'll deploy the web application to it, and then it'll run your integration tests against that. And everything passed. As a matter of fact, let's see here. Oh, here we can look at, well, here, right, yeah, here you might recognize output. This is all the output that is spat out. Gosh, Jetty, complaining about stuff much? But yeah, we can see here, look, started connector here, and this is the same thing as like started server connector right here. So Maven will launch Jetty for you, and then it runs the integration tests. Like here's a project for IT, here's the index.html IT, et cetera, et cetera. Sees that everything passes. But, so this is a much more mature example of an integration test, but it's the same concept as the integration test that you had for projects 1, 2, and 3, in that you're doing, you're working with the interaction of kind of a larger system. In this case, it's actually got the running server, and then for real client code, nothing's locked out. So anyway, I just wanted to leave you with that. As a preview of next time on Wednesday, we will dive into these unit tests as part of refactoring our simple dictionary application into something that uses appointment book and appointment classes and the text appointment profiles. Right. Okay, that's all I got. Anything else though before we break? It's like a dumb question, isn't it? Okay, awesome. Hey, thanks for a good evening. I know there was a lot to cover tonight, and I know that you're probably still totally focused on Project 2. That's all right. That's why we record these things. You know, we'll do the refactoring on Wednesday, and then probably like in another week or so, you'll be like, what was all that stuff about Project 4? This is why we have the recording. Go back to it again. But I wanted to present this up to you now so that we can jump into Android next week and still have enough time for mock programming. Sweet. Okay. Have a great evening, everybody. I will see you again on Wednesday. Looking forward to it. Yep. Bye now.